NASA plans to a 3D Mars colony. Forget about the moon. Building a home on Mars might be the next major leap for humanity. The fourth planet from the sun may be freezing, Martian winters may reach 190 degrees Fahrenheit, arid, and devoid of oxygen, but it is the next stop. Since 2011, the pioneering engineering professor at the University of Southern California, Barak Hosenowitz, has been collaborating with NASA on the idea of establishing a colony on Mars. In 2004, Hosenowitz announced Contour Crafting, CC, a groundbreaking 3D printing technology that allowed him to create a 2,500 square foot structure in less than a day on Earth. The following year, he won first place in the NASA In Situ Materials Challenge for selective separation sintering, a 3D printing technique that uses powder door-like materials found on Mars and operates in zero-gravity settings. So, does NASA really want to 3D print a Mars colony? To infinite and beyond, who hasn't heard of the legendary Toy Story catchphrase that so brilliantly depicts humanity's yearning to explore as far as they can go? There is a reason why space is considered as the ultimate frontier now that we have reached the limits of the Earth. It is the next location where human invention and our intrinsic urge to explore may be used. It's probably unexpected, however, that additive manufacturing is now being utilized to help mankind grow. With the developments in science and technology, 3D printing is now being used in space, from satellites to rockets to food and more. One of the primary ways that 3D printing is now present in space is through testing, with astronauts on the International Space Station attempting to determine if AM is a feasible technology to utilize even in microgravity. Incus and the European Space Agency ESA, for example, have collaborated to evaluate Incus's lithography-based metal manufacturing technique, to investigate if it might be used to create pieces in the lunar base utilizing waste metal or existing surface materials. There are other trials underway on the ISS to assess if bioprinting may be used in the future to assist medical care of long-duration space voyages and planetary colonies. The research is being carried out in the biofabrication facility, and a Wake Forest team recently won a NASA competition with their method for creating lab-grown human liver tissues utilizing AM. Even so, further trials are being conducted, notably at Redwire's additive manufacturing facility. You've probably heard of 3D printed homes on Earth, but did you know that NASA and other groups are investigating the possibility of settlement on the Moon and other planets? Many organizations have been considering space colonization, or the potential permanent habitation of celestial objects other than Earth, for a few years now, as they do study to discover if it is feasible. Many people are concerned about whether we will be able to establish settlements, and additive printing is being considered as a viable answer. There are several efforts underway, beginning with ICON's project Olympus, which seeks to test and create prototypes for a future full-scale additive construction technology capable of printing infrastructure on the Moon. Redwire has a similar concept, having sent materials for the Redwire Regolith Print RRP project to the ISS to see if it is feasible to 3D print using lunar regolith, loose rock, and dirt to make on-demand houses on the other planets and the Moon. There are even more, such as AI Space Factory's Martian Design, which won the NASA Centennial Challenge's 3D Printed Habitat Challenge, as well as LEO 10 and ESA designs. Additive manufacturing is also being utilized more and more in space for your satellites. Several firms, notably Boeing and Airbus, are now working on projects that employ additive printing to build increasingly complicated, lighter parts for their satellites. Airbus, for example, employed additive layer manufacturing ALM last year to produce radio frequency components for 2 Eurostar NEO satellites, and MIT 3D printed ion-powered nanosatellite thrusters. Recently, Fleet Space in Australia reveals plans to deploy 3D printed satellites with the Centauri constellation. And with all of this technology, we arrive to the fundamental goal of all these efforts: Mars colonization. Colonization of another planet may still appear to be science fiction, but for some, it is becoming a reality. Man has been attempting to conquer Mars for many years, and 3D printing has been selected as a technique to aid in these attempts. Indeed, it is often regarded as one of the most promising methods for colonizing the renowned red planet. For example, in 2020, NASA deployed the Perseverance rover to Mars, which had 11 3D printed metals, pieces, and tools. This enabled low mass and high precision targeting that would not have been possible with traditional production. Another project comes from Delft University of Technology, which created zebra robots capable of tunneling beneath Mars' surface to produce three-dimensional, printed subsurface dwellings. The robots can interact with one another and collaborate on activities such as excavating trenches and constructing 3D printed objects. Because it is less susceptible to heat variations, the underground dwelling area may be suited for prospective colonization. Finally, Icon and Big Jark Angels groups accomplished the most ambitious project in the area for NASA. They developed a realistic simulation of a 3D printed dwelling named Mars Dune Alpha. The plan is to transfer it to Mars in order to enable long-duration exploratory space missions. However, we must also innovate in terms of transportation. Many organizations want to create rocket engines rapidly, and changing production methods is the simplest way to accomplish it. As a result, space firms are looking to 3D printing for assistance. Engineers are increasingly adopting the SLS technology to 3D print rocket engines, parts made of a copper alloy powder that can endure high temperatures. Several recent initiatives, such as those of the Spanish business Pangea, utilize 3D printed rocket engines. This firm creates and commercializes revolutionary 3D printed combustion devices composed of cutting-edge materials. They created a 3D printed rocket engine that is 15% more efficient than standard rocket engines. NASA, one of the most prominent businesses in the space sector, is also developing tomorrow's rockets through the RAMPT, Rapid Analysis and Manufacturing Propulsion Technology Initiative. NASA is utilizing additive manufacturing to build massive space rocket engines. Finally, the Australian government awarded Speed a $1.5 million grant for a project that would utilize its proprietary cold spray technique to print rocket engines out of metallic material, among other things. In addition to particular part manufacture, additive manufacturing is being utilized in the aerospace sector to create 3D printed rockets. This expanding trend is allowing industrial businesses to lower the weight of finished items. Among them is Relativity Space, a US firm that has enjoyed exponential development in recent years, presenting itself as one of the most funded 3D printing companies. Its Terran R project aspires to be the world's first entirely 3D printed and reusable rocket, capable of launching over 20,000 kilograms into low Earth orbit in a reusable form. Terran R is expected to launch from Cape Canaveral in 2024. SpaceX, on the other hand, began using additive manufacturing in 2014 with the purpose of producing parts for its rockets. SpaceX is now adopting 3D metal printing to expedite the production process in order to achieve its aim of populating Mars by 2050. In fact, the technology permits it to construct rockets that can be reused an unlimited number of times. Because many space mission parts are made of aluminum, titanium, and steel, NASA is also collaborating with a number of small firms to develop metal printing capabilities. On Earth, selective laser melting is the dominant metal 3D printing process for aircraft. Metal powder is put onto a build plate from a hopper in this procedure. Each layer that is deposited is roughly the thickness of a human hair. A laser then selectively melts and fuses the powder. These systems, however, are quite huge and demand a lot of electricity. Furthermore, the powders are flammable, posing a respiratory hazard, and would be difficult to manage and control in a microgravity environment. Due to these constraints, NASA has considered other processes for adaptation to space. In addition to SLM, ultrasonic techniques that use force and vibrations to join adjacent layers of metal foil, wire plus arc technology that use a welding process to deposit and fuse subsequent layers of metal wire, and bound metal depositions type methods that use filament or pastes of metal particles packed in a polymer binder. Could space manufacturing reduce the long-term expense of exploration? That is dependent on a variety of things. Humans must be involved in the process somewhere along the way. If they're there in person, they will need to be housed, nourished, and entertained in between tasks. There is a time delay to consider if they are functioning from afar. On Mars, the usual 20-minute gap between transmission and reception means the rovers employed there can't travel very far. Perhaps our best chances of success in that domain would be on the Moon, where the wait period is barely a few seconds. Another idea is to make robots much intelligent. If they could employ problem-solving abilities, recognize when a typical procedure or environment changes and how to react, and work together, they could be able to accomplish at least basic manufacturing with the robots in sight. Artificial intelligence research is ongoing on Earth. Who knows, things may look very different in a few decades. Whatever happens, there is no question that a new era of space exploration is on its way. So, what are your opinions on NASA's intentions for 3D printing?